So what does it mean to say that your car has a 12-volt battery? Well, if you're driving a normal car, if you're driving a Tesla, it might have a different volt for the battery. But if a particular car has a 12-volt battery, what does that really mean? Well, when you take the volts recorded on a battery, such as a 12-volt battery, what it means is that there is a difference in potential of 12 volts between the terminals. Now, let's look at this battery. So one terminal, we will say, is the negative terminal. This terminal is at the low potential. Now, remember, electric potential is relative. The value of electric potential itself is meaningless unless you can compare it to another value. So saying that this negative terminal has low potential, well, that low potential could mean that the negative terminal is at, and I am not kidding, 1 million volts. Now that seems like an insane amount of volts for electric potential. But it's not unreasonable. It could be 1 million volts. It could be 1 billion volts. It could be negative 20,000 volts. Because it's not that value of voltage that matters. It's the difference in potential between 2 points. And this is where the high potential side, the positive terminal of the battery. Positive because it's at a higher volts than the negative terminal. So if our battery is a 12-volt battery, and if it's fully charged, that must mean that this high potential terminal, this positive terminal, is at 1,012 volts. Because voltage is just the phrase we use to represent a difference in potential. And that difference in potential is calculated by taking the actual difference in potential, pretty obvious, huh, between the two terminals. So in this case, if one terminal is at 1,012 volts and the other terminal is at 1 million volts, then the difference in potential is 12 volts. And this is where we get our 12-volt battery. This is also true for a AA battery. Now, you might know that a AA battery is a battery that, fully charged, is rated for 1.5 volts. So what that means is the difference in potential between the negative terminal and the positive terminal is 1.5 volts different. So let's see what that might look like for a typical AA battery. And for this example, let's say the negative terminal is at minus 1 billion volts. Okay, well, if the negative terminal is at minus 1 billion volts, and this is a 1.5 volt battery, that must mean the positive terminal is at minus 999,999,998.5 volts. Now, that positive terminal in relation or relative to the negative terminal will give us a potential difference of 1.5 volts. As you can see here, that potential difference is the positive terminal's volts minus the negative terminal, which is minus 999,999,998.5 volts minus a minus 1 billion volts. And if I did my basic algebra right, this should end up being a positive 1.5 volts. So the moral of the story is this. The actual value of volts at a point in space doesn't matter if you want to establish a potential difference. What matters is the difference in that electric potential between 2 points in space. And if you have a difference in potential, you can do work to move charge, which is a key for circuits.